Now this is you. Stick around to find out. Okay, see guys, that's not even a story that I'm reading to you. It's actually an analogy that can help you understand asynchronous concepts. You know, you've had asynchronous programming being tossed around in programming, especially web applications and mobile applications. Now, asynchronous programming, that you add async on the function signature or declaration, and then you add await to the actual function statement here, like the tasks that are in the function block. Async, then await. So if you have an operation that is input output bound, then you add await to that. It can suspend this function and wait for the results, or wait for the promise to resolve, and then get you back the results, which you can then use in the subsequent statements of this function. Now, you probably used this async await a number of times. Maybe you understand it, maybe you don't. But trust me, this video should be the very last video that you need to understand asynchronous programming, where we add async and await. In Python, in JavaScript, TypeScript, we have them, and you've used them probably. Now, in programming, we have two types of operations. Let me just mention two. So we have input-output bound operations, and then we have CPU bound operations. Now, what is the difference? The difference is input-output bound operations. These are operations that involve sending something over a network, or they take time to they take time to complete. A good example is you sending a file over a network, or you're downloading a file from the internet. It will take some time before it completes, right? And then we have CPU-bound operations, which involves just calculations, complex calculations, algorithms, and all. So these kind of tasks, they just need a more powerful CPU to perform these calculations. That is, let me just say, in the system, like adding, addition, multiplication, any arithmetic operation, Think of this. When you are sending something over internet, if at all your computer has to halt all operations and then finish sending this over the internet, then it means some other tasks will be on hold or will be starved of the resource that is currently being used by the I/O operation, that is sending something over the internet, reading from a disk, or writing into a disk, something like that. Now, here is where asynchronous programming comes in, where the moment we initiate that I/O bound operation, like sending a file or reading a file or writing into a disk, we then suspend this function that called this operation. And then we tell the computer, you can now go and do other things while we wait for the results from the download, from the writing, or from the read from the disk that you're waiting, Yeah. So then your computer goes back and does other operations. Let's say there's a calculation somewhere, it goes and does it. There was just some Word document open, it goes and does it, And then once we get the results, now asynchronous operations, they return to you a promise. And this promise has to be resolved so that you can use the result of this operation on the subsequent tasks. Let's say you're fetching users from the database. Once you fetch them, you want to assign them to a variable or just render them in the UI. So once this function resolves, or this operation resolves, the promise resolves, you get now your data back, and then you can use it. Now, stick with me until the end of this video. It will be long. I don't want to lie to you. It's going to be at most 10 minutes of video. And then I'm going to give you an analogy that can help you understand asynchronous, concurrency, and parallelism once and for all. Okay, so this is just concurrency and async await. Now, the details can be found in a function, but then let's look at something real quick. If you are using a third-party library, leave that alone, and then declare, leave that alone. Let's come here. Now, async await or asynchronous function, how do you know a function is asynchronous? By just looking for the async and await keywords in that function, and that's it. That's how you know that a function is asynchronous. Now, let's come down. Why do we even need asynchronous functions in our code? Let's look at this. Asynchronous code just means that the language has a way to tell the computer or program that at some point in the code, it will have to wait for something else to finish somewhere. Let's say that something else is called a slow file. Asynchronous code just means that the language has a way to tell the computer or the program that at some point in the code, it will have to wait for something else to finish somewhere else. Let's say that something else is called a slow file. Stay with me. So during that time, the computer can go and do some other work while slow file finishes, right? Read that again. Then the computer or program will come back every time it has a chance because it's waiting again, or whenever it finished all the work it had at that point. And it will see if any of the tasks it was waiting for have already finished doing whatever it had to do. What happens next? Next, it takes the first task to finish, let's say our slow file, and then continues whatever it had to do with it. The wait for something else normally refers to I/O operations that are relatively slow compared to the speed of the processor and the RAM of the memory. So this is relative to the kind of computer that you are using, its performance. Now, this kind of input-output operations that are slow include things like sending data from the client to be sent through the network, data sent by our program to be received by client through the network, contents of a file in the disk to be read by the system and given to your program, the contents your program gave to the system to be written to the disk, a remote API operation, a database operation to finish, a database query to return results, and etc. and etc. Now, as the execution time is consumed mostly by I operations, they call them IO-bound operations. It's called asynchronous because the computer program doesn't have to be synchronized with the slow task, waiting for the exact moment that task finishes while doing nothing, to be able to take the task results and continue the work. Instead of that, by being an asynchronous system, once finished, the task can wait in line a little bit, some microseconds, for the computer or program to finish whatever it went to do, and then come back and take the results and continue working with them. For synchronous, contrary to asynchronous, they commonly also use the term sequential, where like one operation has to complete for the next, like in that order. Because the computer or program follows all the steps in sequence before switching to a different task, even if those steps involve awaiting. Now let's come here. Now this is the real story. This is the real analogy. Now, stay with me. This idea of asynchronous code described above is also sometimes called concurrency. It is different from parallelism. Concurrency and parallelism both relate to different things happening more or less at the same time. But the details between concurrency and parallelism are quite different. To see the difference, imagine the following story about burgers. Now we have concurrent burgers. You go with your crush to get fast food. You stand in line while the cashier takes the orders from the people in front of you. Now, this is you and your crush, and then there are other guys in front of you that have to be served, then you'll be served. Now you stand there waiting for your turn. Then it's your turn. You place your order of 2 very fancy burgers for your crush and you. Now this is you here. You're now ordering 2 burgers. One for you and one for your crush. And of course, you guys are Fast API fanatics. You see you wearing Fast API t-shirts or merchandise. And then the cashier says something to the cook in the kitchen so they know they have to prepare your burgers, even though they are currently preparing the ones for the previous clients. Stay with me, okay? So this is the cashier telling the cook, like, they need to prepare 2 more burgers, one for me and for my crush. So I pay. The cashier gives you the number of your turn. It's more like being given a ticket, Then once your burger is ready, They will call you, go pick your burgers. Fantastic. So I'm picking my ticket here, ticket number 3. Now, while you are awaiting, you go with your crush and pick a table. I sit and talk with my crush for a long time, as my burgers are very fancy and take some time to prepare. So I am doing something, like I'm waiting for my burgers to be ready. But then, as I am sitting at the table with my crush, while I wait for the burgers, I spend time admiring how awesome, cute, and smart my crush is. Look at that. I've ordered my burgers, and now I have to wait. But while I wait, I spend my quality time admiring how my crush is beautiful. Fantastic. So this is me, this is my crush, and this is me. Now, while waiting and talking to my crush from time to time, I check the number displayed on the counter to see if it's your turn. To see if it's my turn already. Then at some point, it's finally my turn. I go to the counter to get my burgers and come back to the table. Now me and my crush eat the burgers and have a nice time. So, as you can see, just still me and my crush eating burgers and having quality time, nice time. That's it. Now, think of it this way. Imagine you are the computer or program in that story. Now, while I am at the line, I am just idle, waiting for my turn, not doing anything very productive. But the line is fast because the cashier is only taking orders, not preparing them. So that's fine. Then when it's my turn, I do the actual productive work. I process the menu, decide what I want. I then get my crush choice. I pay, check that I have given the correct bill or card. And then I also check that I am charged correctly. Then what next? I check that my order has correct items. But then, even though I still don't have my burgers, my work with the cashier is on pause because I have to wait for my burgers to be ready. But as I go away from the counter and sit at the table with a number for my turn, that is the ticket number, I can switch my attention to my crush and work on that. At this point, I am again doing something very productive, that is flirting with my crush. Then the cashier says, I am finished with doing the burgers by putting my number on the counter's display. But then I don't jump like crazy immediately when the displayed number changes to my turn. No one will steal my burgers because I have the number of my turn and they have theirs. So I wait for my crush to finish the story, which is like the current work being processed. And then I smile gently and say that I am going for the burgers. Then I go to the counter, which is the initial task that was being processed, but now it's finished. I pick the burgers, say thank you, and take them to the table. That finishes the step or task of interaction with the counter. That in turn creates a new task of eating burgers. But the previous one of getting burgers is finished. Now see what happens, what I was explaining. While we are performing an I operation, which is time consuming, we release the computer to go do other things. That is now me going back to the table to flirt with my crush, like just sitting there staring at her, admiring how beautiful she is, And then, while that burger is being prepared, which is the asynchronous operation we are waiting for, we're having some good time. Once it's done, the computer will send a signal that this task is done, and now I can take its results and then use them in other operations. The promise has resolved, and the result is returned. So I can take this result and use it in other operations. So here, the burgers are ready, and so I can go pick them up and then come and enjoy our burgers with my lady here. That is how async await works. While still querying for the database, the computer can go do something else. And once the database operation is complete, I can come check. If it's complete, I pick them up and do something else. Now let's now talk about parallel burgers. Now let's imagine we have concurrent burgers and now we have parallel burgers. So you go with your crush to get a parallel fast food. You stand in line while, let's say, several 8 cashiers that at the same time are cooks take the orders from the people in front of you. Everyone before you is waiting for their burgers to be ready before leaving the counter because each of the 8 cashiers goes and prepares the burgers right away before getting the next order. So you have to give the order, and then the cashier, who's also the cook, has to go prepare them first, come back to you, give you your burgers, you pay, and then they can now serve the next customer. Then when it's finally your turn, you place your order of 2 very fancy burgers for your crush and you. You pay. Again, just me and my crush, like always. Now, the cashier goes to the kitchen, you wait, standing in front of the counter, so that no one else takes your burgers before you do, as there are no numbers for turns. Just us here helplessly waiting for our burgers to be ready. And as you and your crush are busy not letting anyone get in front of you and take your burgers, whenever they arrive, you cannot pay attention to your crush. This is synchronous work. You are synchronized with the cashier and the cook. You have to wait and be there at the exact moment that the cashier or cook finishes the burgers and gives them to you, or otherwise, someone else might take them. Now you see how that is happening. Then your cashier or cook finally comes back with your burgers after a long time waiting. They are in front of the computer, in front of the counter. You take your burgers and go to the table with your crush. You just eat them and you are done. There was not much talk or flirting, as most of the time was spent waiting in front of the counter. In this scenario of parallel burgers, you are the computer or program with 2 processors, you and your crush, both waiting and dedicating their attention to be waiting on the counter for a long time. The fast food store has 8 processors, which are cashiers or cooks, while the concurrent burgers store might have had only 2, 1 cashier and 1 cook. But still, the final experience is not the best. This would be parallel equivalent story of burgers. For a more real-life example, blah, blah, blah. In other words, guys, look at that. I'm just giving you like a snippet of how asynchronous operations work. I'm attaching this link here in the video description. Ensure you check it out. There are also examples here which you can look into, look into these examples, and then let this be your final video that helps you understand asynchronous operations, async and await, without writing a single code. That was it for today. Osego Codes signing out.